All right, so it's been a while since we did these, so I put some warm-ups together real quick. You have 3 sections on Friday's quiz. The first section is just equation solving like this. Now I'm going to save time, go through these, but please be paying attention. You're welcome to take some notes. These you would need to rewrite as powers that are the same base. Does anybody know what they're both the same, what same base we could do? Yeah. This is 2 to the what? 2, 4, 8, 16, 32, 2 to the 5th. Everybody good? And then outside of there is an x minus 1. And this is just 2 squared, but outside of there is an x plus 5. And what do we do with exponents when it's a power and a power? Multiply, yes. So we will need to have a 5 times the quantity x minus 1 equals over here 2 times the quantity x plus 5. So if we distribute, somebody tell me if I make a mistake here. I got x equals 5. Did anybody follow my work? Add 5, subtract 2x. I think we're good. So someone could put it back in and check if we want it on a calculator, but this is one of the questions on the quiz is like that, where you have to make them a like base and get an exact answer. So the reason I didn't do log of both sides, which I could have in theory done the log of both of these, okay, is I won't get an exact answer. I'll get a crazy decimal. Okay, you always want to try to rewrite them as powers of the same base first. All right, this one is everybody's least favorite. Does anybody remember what we did to this? Yeah, we have to factor. If e to the x is u, this is currently u squared plus 3u plus 2. So how would that factor? That's pretty straightforward, right? U plus 2, u plus 1. Everybody okay? So I'm going to write it as e to the x plus 1 and e to the x plus 2. Did I do something wrong? Because I'm thinking this is going to have no solution. I think I should have checked this problem out beforehand. Because what's the next step supposed to be? We have to solve for x. So how do we get the x out of the exponent? Yeah, take the log of both sides. So we'd have x times the natural log of e equals natural log of negative 1. But can you take the log of negative 1? No. So same is going to happen over here, right? We're going to have ln of negative 2, which we also can't do. So this one has no solution. But at least we reviewed the idea. We'll do some more tomorrow. All right, what happens when we have logs all over the place? Can I just cancel them all out? What do I have to do? When can I cancel them? How's that? It's a better question. Okay, but it is on both sides here. Yes, if we have 1 log equal to 1 log, okay, then we can get rid of the log because whatever the problem is has to be equal. Okay, so what do we do with a plus? Yes, we change this to the log of x times x plus 7, and over here we have the log of 18. Now can I get rid of the logs? Yeah. So I have x squared plus 7x equals 18. Should I factor an x out over here? Someone always does something like that. No. We need to make it equal to 0 and factor, right? All right, so I get, how does that factor? Plus 9 minus 2, does that work, guys? Negative 9 and 2, are we done? Why aren't we done? Yeah, can you put a negative 9 in here? Can't take the log of a negative number. If you put a 2 in, you'll have the log of 2 plus the log of 9 equals the log of 18. Does that seem okay? You could check it on your calculator, but it is multiplication, so it'd work. All right, what's wrong with 73 though? Why is it different than 61? It is a different base. What else though? There's one that doesn't have a log. Everybody see what I'm talking about? Now, I don't think I would give it to you quite in this form, but if we move things around here, add this one over here, add the 2 over to the other side. Everybody okay that I just moved some things around? I can't undo log, so I'm going to have to do something to get rid of it. But first, let's combine these. This would be log base 9 of 9x times x, or 9x squared. Now what? Yeah, I can exponentiate or just rewrite it. Okay, it'll be 9x squared equals 9 squared, or 81. So if I divide by 9, I get 9. If I square root, I get plus or minus 3. Can I do plus or minus 3? No, because I was taking the log back here, so it's only going to be 3. I don't have much room, but okay, so there's one of each kind of those on the quiz. Everybody okay? We'll continue to practice those. All right, today we're starting some nasty looking word problems. Newton's law of cooling. Unfortunately, the warm-ups I just did don't really match with Newton's law of cooling. Okay, we're going to have to do some taking the log a little earlier in the problem. All right, Newton's law of cooling says an object that has been heated will cool to the temperature of the medium in which it is placed, such as the surrounding air or water. The temperature of an object at time t can be given by this, okay, or this, and we're going to use this one. This is the one that will be on the question on the quiz. It's right typed in the question. I think it's also on your pink sheet, but it's on the question. All right. Now, let me go through what this is. T sub F is the final temperature, and that's the final temperature at the time we're talking about. T sub S is the temperature of the surroundings. Okay. I should check. I feel like it might be T sub M on the quiz. It's T sub M or T sub S. It's the surroundings or the medium in which it's placed. Okay. And T sub 0 is the original temperature. K is the constant for whatever substance we're talking about. And T is time. Now, let's talk about all those. So when we pull a cake out of the oven, set it on the counter, the original temperature is whatever temperature the oven was at. Does that make sense, guys? Because it was in there for however long, it's at that temperature. The temperature of the medium or the surroundings is the room we place it in, or the refrigerator, or we set it out on the garage to cool, whatever we do with it, okay? If it was, for example, a hard-boiled egg, we took it out of the boiling water and we put it in a cup of cold water. The surrounding temperature is the cup of cold water. Now, I will tell you, this formula ignores any effect on this surrounding temperature. In other words, if I took a pizza out of the oven and put it on the top of the stove, does it really change the temperature in the kitchen? Not much, right? The pizza doesn't. The fact that we had the oven door open might change it a little. But if I take a boiling egg, a hard-boiled egg out of the boiling water, and I put it in this mug full of cold water, is it probably going to actually change the temperature of the cold water? Okay, this formula ignores that, just so you know. Okay, now if I took this was full, first of all, it didn't have holes, but if it was full of water and I put an egg in there, it probably wouldn't change the temperature of this quantity of water as much, right? So we're kind of ignoring that. All right, so this is Newton's law of cooling. And The cooling constant K we will have to find, okay? And then we're going to plug it back in. So this is a two-step process. So for this first example, please be paying attention because we're not going to have a lot of time to do a million of these before the quiz. A cup of coffee has been cooled from 92 to 50 after 12 minutes in a room that's 22 degrees Celsius. How long will the cup take to cool to 30? Okay, this is part 2 of the question. We do not use this until later. We first have to use this first sentence to find K. All right, a cup of coffee has cooled from, this is the original temperature, to this, which is our current final temperature, okay? After 12 minutes, this is our current T value for time, in a room at 22 degrees Celsius, which is our current T sub S or T sub M, whichever it says, whichever one you're using, okay? So if I plug all those in, it says the final temperature minus the surroundings is equal to the original temperature minus the surroundings. E to the negative, or the opposite of K, times T, which is 12 minutes. All right, this is a quantity, this is a quantity, and it's multiplied by this, and all of this is up in the exponent. So what we're saying basically, guys, is how much off is the coffee from the surroundings? So 50 minus 22 is what, 28? Did I do that right? Okay. How much was it off of the surroundings originally? So 92 minus 22 is 70. And then we have E to the, I'm just going to rewrite this as 12K, negative 12K or opposite of 12K. All right. What do we have to do first? This is what students mess up. Algebra brain first says to do what? Yes, divide by the 70. Okay, and I'm just going to leave it. This happens to reduce nicely, but a lot of times it's really ugly, so we just usually leave it. Okay, now what are we going to do when the variable is in the exponent? Going to have to take the log of both sides. What kind of log do we probably want to do since it's an E? So we're going to do the natural log of 28 over 70 equals the natural log of E to the negative 12K, but what are we going to do with that negative 12K? Can move it out in front here. And once we do that, what's the natural log of E? It is 1. Make sure that K is showing up there. So what do we have left to get the K by itself? Yeah, divide by negative 12. Now, this is a cooling process, so the K value is going to be negative. Actually, it's going to turn out positive because of the negative down there, I think. Okay, so on the home screen, I should be doing this so you can see it. ln of, was it 28 over 70? Did I remember right, or is it the other way around? Thank you. Close parenthesis, and then divide by negative 12. Okay, so I get a cooling constant, and we're going to go out several places for these. 0764, can I go out that far? So generally our cooling constant, we're going to go, because it will make a big difference later if we round too much. So we're going to go out 4 places. Okay. Now, we're going to start the problem over. and we're going to say the time to cool to 30 degrees Celsius. The question on the quiz says the time to cool from when it came out of the oven or came out when we poured it or whatever it is. So we're going to go back and call our original temperature still 92 degrees. And our final temperature, what do we want it to get down to for this problem now, for part 2 of this? 30 degrees. Okay. What else are we talking about? The surroundings have not changed, so the surroundings are still 22. All right, but this time we're putting in K is 0.0764, and we're looking for T. So we're going to have, you can see this, we're going to have 30 minus 22 equals 92 minus 22, which is still 70. E to the negative 0.0764 T. So 22 minus 30 minus 22 is 8. Like I said, I'm going to go this side is still 70. E to the negative 0.0764 T. Solving it the same we did before, what are we going to do next? Divide. So we get 8 over 70 is e to the negative 0.0764 T. And then because it's in the exponent, we want to take ln of both sides. So we have the natural log of 8 over 70 equals, this should come out in front, negative 0.0764 T times ln of e, which is just 1. So our final step is to divide by negative 0.0764. And find out how long it took from the time we poured this until it's down to 30. Ugh, I can't type. Anybody get 28.4 minutes? Okay. It's around 28 minutes, 28 and a half minutes. I'm just going to go ahead and leave it 0.4. So, in other words, we measured the temperature at at one time so that we could predict, we could find the cooling coefficient and then predict how long until we finish cooling it. Everybody good? All right, we're going to do this again for a cake. Anybody bake yesterday on a nice snowy day? I turned the oven on, but what did I make? Oh, fish sticks, nothing exciting. A cake is removed from an oven at 350 and cools to 120 after 20 minutes in a room at 65. So we're going to use all that information from that first sentence to find our cooling coefficient. Then later, we're going to use this, okay? We use this only for part 2 of the question. All right, who can help me start? What's the final temperature for the first part of the question? Okay, so this is T sub F. This is T sub 0. I should make that a capital T. And 20 minutes is going to be our little t, and 65 is the room. So that's either the surroundings or the medium, whichever your formula says. All right, so we have final temperature minus surroundings equals original temperature, we're in Fahrenheit this time, minus surroundings, e to the negative k, we don't know, times t, which is 20. All right, do some work, see how far you can get. Have I made any arithmetic mistakes? Is anybody checking me? Was it 55 and 285? Now that I have it covered up. Okay. And then divided by negative 20. 0.0823, anyone? No, yes, maybe? Okay. Now, it's not negative, but as soon as we put it back in, it has a negative on it anyway. Did you get that, Jada? Are you? Okay. Anybody not getting this number? All right. Let's go back and do it. What's changing this time? What are we leaving off? We're making our 90 degrees our what? Our final temperature. And what are we looking for this time? The time. Okay, so we're not going to use this 20 anymore, and we're not using this final temperature anymore. So our new final temperature is 90. The room is still 65. We're still going from the time it came out of the oven. This is where there can be some interpretation. Do you want to know how much longer it's going to be? But in the question on the quiz, it says from the time it came out of the oven. So that's what we're going to do. K is 0.0823, and we're looking for little t. All right. Do I have those numbers right, guys? 25 and 260? What'd you get, guys? Can't hear over that thing. What? Thank you. Did anybody else get 29.5? No? Yes? Did it round differently depending how many places you went, or you got 0.6? Okay. I don't get 0.6. Did I? Oh, I didn't type. Was it supposed to be 0.45? Okay, so it rounds to 0.5, right? Is 20, oh, it's 28.45. Oh, I can't read either. That's a serious problem. Okay. So T is 28.45, which would round up and make this 28.5, not 29.5. All right. 28.5 minutes. Now are we all agreeing? Yes. Did I do it wrong? Yes, this should have been 65 and 65. Oh, I just love when I mess up in my recording, no less. Yes, because the surroundings are still 65. Okay, so someone tell me what this should have been. This is 25, and this is still 285, right? I should have known it should stay the same. 0.0823 T. All right, so I get 25 over 285, and then I take the log. I skipped some steps this time, but what do you get this time? 29.57, so it's 29.6. So almost a half hour. That would be pretty good if our cake could be cool enough to eat in a half hour, right? Or to put frosting on or whatever we're going to do. All right, so this is wrong. What? All right, sorry about that, guys. All right, now we have a half-life question. This is still at the bottom of 9, right? The half-life function is the original amount, the rate is 1/2 or 0.5, x is time over h, where h is the length of the half-life. So the half-life of radium-226, and that's all part of its name, we don't use that number, is 1600 years. So what is that? Is that h or t or x, or what are we going on here? That's the length of the half-life, which is h. Suppose we have a 120 milligram sample. That's our initial amount. I think it actually looks like this on your, what is it? Is it on the pink sheet? Anybody have it? Is it T over H out here, or half-life, or? Okay, so this is equivalent. They just have put the half in for us. All right, so we have 120, 1/2 or 0.5. And we're supposed to figure out how much will remain after 4,000 years. So that's time, or x in this question. It's normally t. So we have 4,000. Ugh, I can't write. Let's try that again. Over h, which is the length of a half-life, or 1600 years. See, guys, the idea is that it only takes half every time you hit a multiple of 1600. So we're not doing this very many times. So when we go 120 times 0.5 or 1/2 to the power of 4,000, make sure you're still in the exponent power, so you need a parenthesis if you're doing this on an old calculator, divided by 1600. I got 21.2, okay? So out of our 120 milligram sample, there is left 21.2 milligrams. How long until there will be only 10 milligrams? Now, you could solve this by graphing, but we're going to solve it algebraically. You have to solve it algebraically on the quiz at one point, so please stay with me here. We want this to get down to 10. If it started at 120, it's halving, but it's only halving every 1600 years, okay? This is very much like a quiz question and a final exam question. The only thing is, it says on the quiz, it says how long until there will be less than 10, and then you have to round differently. But for this one, it says only be 10, so we'll just go with a pretty exact answer here. What do we do first? You can't do 120 times half and get 60. Does everybody understand that? Because this is raised to a power. It's like if I have two, well, that's not a very good example because most of you wouldn't do that, but if I had 4 times 6 squared, it's not the same as 24 squared. Are we good? Okay. So we have to divide by the 120 first. Now, our t is in the, or x or whatever you're using, is in the exponent. So we're going to have to do what? Log of both sides. Do you want to use ln or log? It doesn't matter. Log, okay. So I'm going to do log on both sides. Now, can I get rid of that? I could change it to a decimal, right? But I'm just going to leave this log of 10 over 120. What's the next step I'm going to have to do over here? Yeah, this guy's going to come out in front. And then what? Trying to get t by itself here. We need to divide and multiply. I'm going to go ahead and divide by the log of 1/2. Does that seem okay, guys? But I have to type log twice, just so we're clear. And then over here, I'll have t over 1600, which means I'm going to need to take whatever I get there and multiply it by 1600. So I have log of, what was it, guys? Divided by the log of 1/2. Which you could just use 0.5 is fine. Okay, and I get this crazy decimal. And then to get rid of that divided by 1600 on the other side, I have to take that crazy decimal and multiply by 1600. Okay, so we got 3.58496 times 1600, and it came out 5735.994, whatever you want to write, years. So almost 5736. Now let's go back and talk about this. After 4,000 years, there was 21.2 milligrams left. If we want to get down to 10, it's going to take more than 4,000 years, right? Just so we're clear on this. So does our answer make sense? What was our answer again? Somebody remind me. 5735 roughly. Okay. Then there was a point still on that. Oh, it was almost 36. Okay. Thank you. I couldn't remember. I thought it was. Okay. On the quiz, it's going to say till there's less than 10, and then you'd have to round up, because at 0.9, you know, somebody type it back in real fast. If you had said there was originally how much? 120 times 1/2 to the power of, somebody to tell me it again, 5735.9 divided by 1600. All right, so we're actually at 10.0001. If it said less than 10, you would have had to round up to 5736 years so that it went below, okay? That's a question later for the quiz. All right, let's switch over and look at worksheet 10. How do you feel about Newton's law of cooling? Feel like you got 2 solid examples, even though I messed up on one that you can go back and look at? Okay. Then what I would like to try is, let's do this bears question, because this question is on the quiz as well. It's actually in a different section of the quiz, but we're going to graph this equation. This is called logistic. It's going to approach, it says logistic growth. The growth of most populations in an environment are most correctly modeled by a function of this form. Okay, so we have a population of bears in a wildlife area, and it's modeled by this, where t is time. So we are going to go to our graph. Can you go to y equals? And we're going to type in this equation. Now, we're going to need parentheses. We're going to do 300 divided by parenthesis 1 plus 19. Could I make that 20? 1 plus 19? Why wouldn't it have already been 20 then? I can't because the 19 is multiplied by this mess, right? So I put an E. Now, I'm going to actually put parentheses up here. You don't need them if you get the little box. But it's e to a power of, and up there we're going to have negative 0.3, because this is negative 0.3. You can type 0.3 if you want. Just make sure you don't put 0.03. X, and then close parenthesis. If you have the older calculator, you have to have those parentheses there. All right, window. What does t represent or x represent? Time. So can we have negative? No, 0. I'm going to go 0 to, I don't know, 25 years maybe? 0 to 25 for my x. Now, this is important, very important. Pay attention. This number on top is generally the maximum population. Okay? So it seems like this is going to reach about 300 bears eventually. So I'm going to leave it at negative 10 and put like 350 for my max. My y's, I have negative 10 to 350. So this is my window. Can't see it. And then I'm going to hit graph. Oh, may need to go out more years. I don't know. But this is the shape I'm getting. This is the shape of a logistic. It's slow growth, then it's faster growth, and then it levels off and is approaching a maximum. All right, so find the number of bears in 0 years. How are we going to do that? We could put a 0 into the equation, but since we've already graphed it, what could we do? Yeah, trace 0. How many bears did we start with? Did anybody else get 15? Okay. 3 years. Go trace 3 and tell me what you get. Rounded to the nearest whole bear. 34 bears. Okay, 10 years. Okay, it's not going to work to go to 30 until we change our window. So we need our window. I'm going to go out to like 50 years just in case. All right, so now I've changed the window a little bit so it does definitely flatten out. How many bears were there at 30 years? Okay. And then the question says, when were there 500 bears? How could we find that? Oh, this says, oh, when was the bear population 50? Okay. So how can we find when it was 50? Anybody know? We could plug a 50 in and try to work backwards, and it would kind of be a nightmare. We could do it, but it'd be a big hot mess. What's the easiest way to do this? Guys, can I just put a 50 in my Y2 and find where they intersect? So when were there 50 bears? You're going to have to know how to do this for the quiz. All right, I can't read that, so I'm going to put it on here. 50 bears at about 4.5 years, yes? All right, so this came out to be, was it 299? This is about 4.5 years. And what will the maximum number of bears be? Did anybody trace out there and see what's happening? If you just trace to the right, out here, it eventually rounds to what? Talked about this at the beginning of the question, guys. This number on top should usually be the max. Everybody getting 300? All right. Now, I am going to skip and talk about number 10 on 11A because we're going to run out of time here. A wooden artifact from an ancient tomb contains 65% of the carbon-14 that is present in living trees. How long ago was the artifact made if the half-life is 5730? So 5730 is the length of a half-life. That's our H. We want there to be 65% remaining of the original. Anybody know how we could do that? Couple different ways. We could say I'm going to start with 100. How much would we be down to then? If my original value was 100, we can use this formula, guys. So if we started, what's 65% of 100? So we'd say we're ending with 65. It's a half-life question, and T, we don't know, but H is 5730. Okay, we could have also started with, I started with 1 gram and now I'm down to 0.65, or I could have started with 1 n sub 0 and 0.65 n sub 0. It doesn't matter, but what's the first step anyway? Yeah, divide by 100, so I'm going to get 0.65. Okay, I'm not doing 11, by the way. And over here I have 1/2 T over 5730. Okay, what's the next step? Log both sides, and it doesn't matter what kind. Bring the T over 5730 out in front. What's next? I would divide the log of 1/2 over here. And then after we get that, we're going to need to do what? Multiply it by 5730. Okay. So the log of 0.65, oh, I'm not on my home screen, divided by, oops, got to close that parenthesis or that'll mess you up, divided by the log of 1/2, I'm going to type 0.5, and then that decimal gets multiplied by 5730, if you can type. And we get, it'll be about 3561.1 years. Okay, so I've done an example of most of the things you need to do, but your assignment, you're probably not going to know how to do this one unless you go in. It's going to be putting it in a table. We can actually do this one together tomorrow, okay? But do the rest of worksheet 10 and 11. If you look on the homework check, does it cross out any of them, or does it just tell you 10 and 11? Just says 10, 11, okay. So you need to do all of them except for 11B where you only had to do the circles. And this number 12 we can save for tomorrow.